work with Amitabh Saxena, well, also from Ergo platform. And the presentation is based on a paper which was written in 2019, and then it was presented at a workshop on smart contracts associated with financial cryptography 2020. Right, so the full title of the paper is Bypassing Non-outsourceable Scratch Proof of Work Puzzles by using collateralized smart contracts, right? So, well, this presentation will be less formal in comparison with the workshop, right? And well, this is seminar, so please feel free to ask questions at any time and yeah, start discussions. Okay, so well, let me present Ergo in the first place. So it's a proof of work cryptocurrency with UTXO model, but also, yeah, very different approach to the contractual capabilities. So it has Ethereum-like expressiveness, well, without Turing complete language. And yeah, the mainnet was launched in 2019, on July 1st, 2019, after like 3 years of development. Right, so the design is based on papers published by Ergo developers, but not only. Right, so it has for the first time in the space also non-outsourceable, or we can say pool resistant proof of work scheme, right? And yeah, let me talk a little bit about contractual capabilities in regards with the context, means execution context, so information available about the blockchain state to smart contract. Right, so there are different levels we can consider. So in Bitcoin, you can access information from UTXO itself, right? And that's basically it. If we are talking about Bitcoin prior to version 0.13, right? So then, well, some information about timing in the blockchain appeared in the execution context. Well, Ergo is allowing more, right? So you can access the entire transaction with inputs and outputs in the execution context for an input to be spent, right? Also, it allows for information from current block header and also some fixed number of previous block headers, right, including proof of work solution. So well, we will use this fact. And yeah, that's it. So Ergo is operating on this level 3, right? Then we can think about well, richer context if we include the entire block with all the transaction or the entire blockchain, right? But then such approaches to the execution context would not be friendly to light clients and so on, right? So with more expressiveness also, more problems are coming. So then, yeah, level 3 is kind of optimal, maybe if we are still concerned about light clients and scalability. Okay. And now let's go to the notion of non-outsourceable proof of work puzzles. Right, so general idea is to prevent outsourcing work to other parties, right? So to prevent pool formation and also renting hash power, right? So yeah, renting hash power and how to prevent it is now probably a hot topic, right? Because of 2 recent attacks on Ethereum Classic. Oh, maybe even more than 2. Yeah, I'm not so sure, but well, at least 2 pretty deadly attacks were performed in recent days, causing reorganizations, well, lasting for thousands of blocks, right? So yeah. And yeah, those attacks were made with hash power being rented on a nice hash market, right? And yeah, then yeah, a lot of talks in ETC community, Ethereum Classic, and well, other communities, what can be done with that. Right, so non-outsourceable puzzles is a particular solution because, well, if you can't outsource work, then yeah, those hash power marketplaces also gone. Right, and about pools, so yeah, if you don't know how they work, so let me explain a little bit. Right, so in a pool, there is pool, which is providing work to participants, and work is usually about a header of a block, and the block is including a reward transaction to the pool, right, already. And yeah, also pool is, well, given some non-space, right, and then workers are iterating through this nonsense. And yeah, and the header, in order to find a solution, right, and once solution is found, it is to be sent to the pool, and yeah, pool is publishing the full block now with reward transaction. And to get paid, workers also usually sending some proofs that they're working. Right, and usually those proofs are about, well, so-called near blocks, so blocks with lower difficulty. Also, well, in the industry, those proofs are called shares. And then workers, miners are getting paid per shares. Well, there are different schemes, but yeah, in general, it's about getting paid for presenting shares, so blocks with low difficulty. Okay, and then if we don't have rented hash power, and if we don't have pools, then well, in theory, such a proof of work scheme is more fair, right? So pool can't censor transactions, and pool cannot attack coins, but yeah, there are maybe no examples even of that. And yeah, well, it means that you are doing work on your own. Well, so, well, at least in theory, this is kind of attractive. So there are a lot of works on such puzzles in the space. And well, the works are about 2 approaches, basically. Right, well, all the works are about using kind of asymmetric cryptography, right, instead of simple, very simple cryptography used in Bitcoin, right, and well, all the works are about embedding some public key into the puzzle, right, so we can call it puzzle public key. Right, and to perform work, a private key is needed, right? So then, well, working on a puzzle is kind of involving kind of signing, right? And yeah, then solution can be verified by using a public key embedded into the puzzle. Right, and then we need to tie this puzzle public key to rewards, right? Well, to make then pool formation at least economically non-viable, right? So if yeah, there is some connection, then usually miner can steal the rewards, right? And there are basically two solutions, right? So first is about making a reward key the same as the puzzle public key, right? So let's call it type 1 non-outsourceable proof of work puzzles. And another solution is well, about having some connection, but kind of weak. So when basically it's about getting work done with puzzle public key, which is fixed, right? But then when puzzle is solved, right, then rewards public key can be modified, right? So then yeah, so that means that the block provided by the pool can be modified also, and miner can run away with modified block. Okay, so there are two well subtypes of that type. We are calling type 2. Right, so in one, well, still some kind of signature is used, then, well, miner who ran away can be identified. And, well, another solution is to provide a kind of zero knowledge proof that correct solution is known. Right, and then science rewards public key can be modified, so then miner can run away and not being identified even. Right, so we are calling this subtype type 2S, where S means strong. Right, and now let's observe the work. So the first one, the first scheme was proposed in a paper which was related to some different problem. So the permacoin paper, which is about repurposing Bitcoin work for data preservation, right? And in this work, so a kind of non-outsourceable proof of work puzzle with proposed by using some float pre-image signature scheme, right? Where if well so some well large enough parts of private key is known, then miner can basically well tie to another public key and run away, right? But still well he can be identified by using some watermark in a header, a block header, for example. And then so there was a follow-up paper about using zero knowledge proofs, right, to hide well miner's identity at all. Right, and then yeah, and the next paper was by Philip Dayan et al. Well, it's called Piecework, Generalized Outsourcing Control for Proofs of Work. And this is about type 1 puzzles, right? So when reward public key is the same as the puzzle public key, right? Then Ergo's proof of work scheme called Autolykos was described in a white paper, well, not published peer-reviewed venue. And the very new paper just accepted to CBT 2020 workshop is about verifiable random function based non-outsourceable proof of work. Right, it is also about type 1 puzzle scheme. Right. And let me describe a little bit, well, Autolykos approach. So proof of work puzzle scheme used in Ergo, and basically all other type 1 puzzles would be the same, but they are not implemented in practice. All right, so in Ergo proof of work, well, a solution is a variant of a Schnorr signature. So it's a big integer, right? So yeah, kind of, well, essentially a signature, which also must be less than a target value, right? Because, well, still we have difficulty and so on. Then, yeah, public key is an elliptic curve group element in a concrete implementation, right? And yeah, so well, the rewards, miners rewards are not set into the protocol. Instead, there is a special contract existing from the Genesis state, which is paying miners, right? And well, it allows miner to get rewarded if yeah, the rewarding transaction is paying to a public key, which is set into block header. Right, and the reward is spendable 720 blocks after. Right, so before that, the reward is time locked. Okay, and then, yeah, we can bypass actually such a non-outsourceable proof of work scheme, right? And now there is even concrete implementation called ErgoPool. And well, the solution, the bypassing solution is based on observation that in a pooling system, the workers don't have to necessarily send the actual reward to the pool. Right, so it is enough to send the same amount as the reward to the pool. Right, then we can use simply use collaterals for that. Right, then the scheme is as follows. So each worker is solving its own version of the puzzle with own private key. Right, so then miner is simply getting the block rewards, right, to its own address. But then the miner needs to send also the same amount to the pool, right? Well, as a reward is not spendable. So as it's not spendable in the same block, then we cannot use a chained transaction, right? And so miner must have collateral to be put in prior, right? And yeah, so this collateral is spendable with a pool transaction once the block is found. And then if we are talking about shares, so proofs that miner is working, then this share in case of ErgoPool is about block header, right? But also the proof of inclusion for the pool transaction. So the transaction which is paying collateral to the pool. right? And for this proof of inclusion, so it's enough to have a block header and also a Merkle path to the transaction, as well, Ergo block header is containing transactions Merkle root like Bitcoin. Okay, and then this share is pretty small in practice, less than 1 kilobyte, so not a problem at all to send these shares the network. Okay. All right, so there are some problems with this simple scheme. So this pool transaction it can be well replayed in certain situations, right? So then the solution is to also tie well the collateral box to the fact that miner public key in the block header is corresponding to the well actual public key used, right? And yeah, there are some details I'm going to skip likely in regards with withdrawal to be done at any time, and also well as likely few collateral UTXOs been used. We also need for one-time lock, but yeah, you can find these details in the paper. Right, then yeah, so ErgoPool is then a pool for Ergo, which is bypassing non-outsourceability, and it can be used for other cryptocurrencies with non-outsourceable schemes, right? But yeah, most of these schemes are well, all the schemes except of Ergos are on the paper still, right? And yeah, then this pool is also providing good censorship resistance, as any miner is generating block candidates on its own. Right, then yeah, ErgoPool is likely working for all the type 1 schemes, right? The reward public key is the same as puzzle public key, but we also have a solution described in the paper for type 2 puzzles, right? So when reward public key is different from miner public key, then yeah, it becomes more tricky. But the general idea is that still there can be some watermark. Well, the pool can ask for in order to pay for shares. Right, so even if rewards public key can be changed, this watermark is stable, right? So usually, well, as there is no any concrete implementation of type 2 puzzles, so we can just imagine, right, some examples. So if this cryptocurrency would be like Ergo, so containing miner public key in a block header, then we can tie proof with that, right? Tie share with this field. Otherwise, we can do watermarking in a more subtle way. So, for example, well, the non-space can contain some watermark as well. So there is a concrete example in the Andrew Miller's paper, the second one. Okay, so yeah, there could be different solutions based on a concrete implementation, but usually, well, some solution can be found likely. Okay, so ErgoPool is still not the most decentralized solution, right? So any miner is working on its own, but still the pool can cheat with shares, right? So there are some solutions for even better and more decentralized pooling, like smart pool and P2P pool, where pool is basically a smart contract in case of smart pool, or even a separate blockchain, well tied to the Bitcoin blockchain, as in case of P2P, P2Pool. Well, these pools are not popular, so yeah. So concluding, and yeah, well, throwing seeds into the discussion, which will be started after this slide. So with richer and richer contractual capabilities, and also with wider knowledge we have about consensus with time, right? So a lot of questions, a lot of research possibilities arise around consensus and contracts interaction. Right, so what we already know in this space. So we know the first paper published, and yeah, even in the space of informal research, probably the first forum posts on Bitcoin Talk from all times about that. So miners can be bribed, right? Then we have hash power derivatives coming to well, contractual rich blockchains like Ethereum, right? So then miners can cheat, right, with such derivatives. So for example, if there is a future instrument set for hash power around a certain moment of time, then a miner can, for example, pull out well, his hash power in order to well, profit from these futures, right? So this work is about another interesting conjecture. So pools can be formed even if proof of work scheme is non-outsourceable in most cases, right? So yeah, I forgot to mention. So yeah, from the yeah, taxonomy of proof of work puzzles, we have non-outsourceable proof of work puzzles. So after our work, so only type 2S puzzles probably remain non-outsourceable, right? So well, but those puzzles are not very practical because well, they require for heavy validation, and heavy validation is not a desirable property for a blockchain. Okay, so we also have proof of stake, right? So all the previous well, concerns about proof of work blockchains. But in proof of stakes, so now we have a rise of DeFi, decentralized finance, and then we can have staking in DeFi clashing with lending. So for example, if you can put your Ethereum tokens with higher interest rate into some lending contract, then yeah, then you are not staking them. Right, if staking interest rate is lower. And then it's about lower security for the proof of stake blockchain, right? So then with these DeFi contracts, we are getting into the very interesting and maybe risky clash between staking and DeFi, so between the basic security of the blockchain and contracts on the blockchain. Okay, and well, I think a lot of new problems will be discovered in coming years for the consensus and complex interaction. So that's probably everything. And yeah, I will be happy to answer your questions, and let's start discussions.
Well, thank you, Alex, for the presentation. That was great. It was interesting to see a few more details of the paper compared to the financial crypto workshop. Let me start with the first question. And I want to ask, what are the challenges in defeating non-outsourceability in the strong non-outsourceable case? Why isn't it possible?
Oh, so in this case, well, still, well, maybe some implementation will be followed, but unlikely. So in this case, so there is no solution at all to be presented on the blockchain. So instead of solution, right, like nonce, right? So you are presenting just zero knowledge proof, right? That there is well, correct solution, right? And then there is no information well, we can use likely. So I don't know. So well, the only maybe way we can think about is to watermark the proofs themselves, but yeah, I'm not so sure that can be well any solution in regards to that. So yeah, I mean, in theory at least, well, to the moment, we can think that those those type 2s schemes will be non-outsourceable. But yeah, I mean, so it's well, just a non-proven statement, right? So we need to see some concrete instantiation. Maybe well, it will give some possibility for watermarking. Right. So the problem is that yeah. So the miner can run away, right? But yeah. So there is some footprint, right? We can use to seize the miner's collateral, and well, in this case, in this strong non-outsourceable puzzles, so. Well, maybe there will be not footprint at all, but yeah, it depends on a concrete implementation after all. So maybe a concrete implementation will still allow for some footprinting. Watermark. Any more questions?
Okay, well, if there aren't any more questions, let's thank Alex for the presentation. Yeah, we'll welcome you to the next seminar on Wednesday. We have two more lined up. One is by Dimitris Karakostas, and the other one, the next one is by George. So check the crypto website for the schedule and the topics. And thank you all very much for attending today.
All right, thank you, everyone.
Thank you. Bye.
Bye.
Bye, folks.